these deep neural networks are very powerful. What is a deep neural network? A neural network with multiple hidden layers. These are very powerful. But the problem is, with great power comes great responsibility. So when you are building these deep neural networks, you have to be responsible, isn't it? You have to be very careful. In the sense, we cannot try anything just like that. Maybe I cannot simply take 20 layers, each with 20 nodes. Let me see whether it will work or not. These kind of experimentation may not be possible, because something here and there, if we move, let's say 20 layers, 20 nodes, maybe sometimes what you will have is, you will have two major problems when you are working with deep neural networks. What are the two major problems? Sometimes the execution time will be almost indefinitely long. Maybe sometimes it will take 2 weeks, 3 weeks, even 1 month execution time. Sometimes you may get into the overfitting and underfitting issue. So you have to be careful. So there are some hyperparameters, by fine tuning them carefully, sometimes you can avoid long execution time. Sometimes you can avoid overfitting and underfitting issues by fine tuning them carefully. So these are kind of practical problems that you will face when you are working with neural network. These are not like concepts that we have to learn. These are the things that we will face as an issues. Here, what I'm sharing is some of the tips and tricks that you can apply when you are working on deep neural networks, when you are working on any of the image processing or any of the deep neural networks when you are building, then you can use these tips and tricks. The first question that I got was, how do I really configure my network? Two, three times, two, three people asked in this session itself in last 10 minutes, isn't it? What is it? How do I configure? So shall I keep one hidden layer with these many nodes? Shall I keep two hidden layers? Shall I keep three hidden layers? How many hidden layers shall I keep? Then this is the output layer. Shall I keep three hidden layers with 10 nodes each? Shall I keep one hidden layer with 5 6 nodes each? Shall I keep two hidden layers with 15 nodes each? How do I configure that? When you are in doubt, here is a trick that you should follow. This is suggested by experts. When you are in doubt, always build a large network. If you are in doubt, you don't know how to configure your network, you are starting with a blank slate. Configure a large network. Obviously, when you configure a large network, relatively large, do not build crazily large network, build a relatively large network. Obviously, when you build a really relatively large network, what will be the issue with that particular model? What will be the resultant model like? Think about it. When I build a larger than optimal network, your optimal network is a particular size. When we are building a larger, maybe more nodes I have given, one or two more layers also I have given. If it is a large network, then what will happen? Let us suppose I require only two nodes, two hidden layers. I require only two hidden layers, and I require only 10 nodes in each of them. 10 nodes each. However, I took three hidden layers, maybe 15 nodes in each of them. Then what will happen? All of you think about it. What will happen to the resultant model? What will be it like? The resultant model will be overfitted. Do you agree with that point? Too many hidden nodes, too many hidden layers, then the optimal value will result into overfitting. Do you agree with this point? Think about it, all of you. Too many hidden nodes, too many hidden layers, they will result into overfitting. Yes or no? So here what experts say is, build a large network but avoid overfitting with a trick. Avoid overfitting. That means when you are in doubt, build a large network. Don't worry, build a large network. But avoid overfitting. Hey, how do I avoid overfitting even after building a large network? By keeping their weights at a lower value. By keeping the weights of the hidden nodes. Do you have The issue of too many hidden nodes, have too many hidden nodes, no problem. However, keep these hidden node weights under a particular value. Do not let each of these hidden nodes inflate. Keep them under a certain limit. Do not let these weights really grow higher. That particular process is known as regularization. What is regularization? Regularization or weight regularization. What do you mean by weight regularization? You have a large network, but do not let the weights to grow really large, naturally large. Like let us suppose the weight value originally it has to be 0.58 in the algorithm. If that is the result, keep it at a lower value, maybe 0.32, like that. Do not let this grow. How do you do that? Using regularization. So what is the problem of overfitting? When does overfitting occur in neural networks? When does it occur? When you have too many hidden nodes, too many hidden layers, when the network is really large, then you will have overfitting. How do you avoid overfitting? You reduce overfitting by, one thing is, what is one method? You drop one hidden layer, you drop one hidden layer, you drop few hidden nodes, make the network simple, avoid overfitting. That is one way. But that looks like a trial and error method. All of you already thought about it. I can try to take different architectures. Maybe one of the architecture will be optimal. I think you also given it a try, but you found it is not convincing. You're not getting in a deterministically. You are not approaching the right value. That's why you're asking that question. How do I really configure it? Is there a better method? Then what experts suggest is, let us have a larger network. Then how do you deterministically make this network? How do you avoid overfitting? One simple trick is you drop the hidden layers, hidden nodes, but I don't want to do that. Keep the hidden layers, keep the hidden layers, but give them less weightage. Keep their weights at a very less value. How do you do that? So here is the trick. This is the original cost function, minimize sum of squares of error. This is known as error function or the cost function. Usually what do? We minimize the error function. However, to this error function, we are going to add this error function plus lambda into sum of squares of weights. So what are we minimizing? We are not only minimizing the overall error, we are also minimizing plus an addition sum of squares of weights also we are minimizing. That means we are keeping weights at a lower value as well. So this is known as cost function regularization. This is the actual cost function or the error function. What we can do is, this is a theory part of it. We don't do it manually. There is already a package that will take care of it. But internally, how it will be done? You have the actual cost function. This is what we usually minimize the sum of squares of errors. But here, what we want to minimize is the new regularized error, or the new regularized cost function is original error plus lambda into sum of squares of weights. This lambda is known as regularization parameter. This lambda is known as regularization parameter. Now think about it. If you have a really large network, all of you try to answer these questions. If you have a really large network, in that really large network, you are applying regularization and lambda is in your hand. You can fine tune this. It is in your hand. If you set lambda to be too low, lambda is almost zero. That's how you set it. It is in your hand. You have to set this. You have to give this. You give almost lambda equal to zero. Can you think what will happen to the result of this model? You have regularized error, but you set lambda to almost zero, very low or almost zero. What will happen to your final model? Think about it. All of you need to answer. When the lambda is too low, almost near to zero, what will happen? Think along with me. When the lambda is zero, almost this term will be negligible. Almost this is gone, zero. Almost this one will be zero. Now try to think and answer. If lambda is zero, this term will be almost zero. and I have a really large network. My actual cost function, new regularized cost function, almost same. If my actual cost function is very similar to new regularized cost function, what will happen? Because I already have a really large network, I'm starting from there. What will happen? Try to answer this question, all of you in the chat window. If we have lambda almost zero, if we have lambda almost zero, my actual cost function, new regularized cost function is almost same. If that is the case, then I will be falling into overfitting. Yes or no? Do you agree with that point? Now, if the model is overfitted, you know what you are going to do. Do you change the network? Okay, you tried lambda equal to 0 and your model is overfitted. Are you going to change the network architecture? Do you think you have too many hidden nodes, hidden layers? Are you going to disturb the network? What is your next step? Are you going to change the network architecture, or you will freeze the network architecture as it is and you work with something else? You want to go deterministically. You want to learn everything in the next step. It has to be better. You will increase the lambda. Yes or no? Maybe you tried lambda equal to something like 1.5 or something. Lambda value can be tried somewhere between 0 to any infinity value, but usually it is tried between 0 to 0.01 or something. But let us suppose you tried lambda as 0 point, or not 0 point, you tried a slightly higher value, crazily higher value. Let's say lambda equal to 2 is what you have tried. Think about it. If lambda is too high, if lambda is too high, if it is too high. Now, to keep this whole function, the whole error function under a very small value, to keep it at a lower value, if lambda is too high, I have to anyway minimize this, which will be done automatically. What I will be crazily minimizing, tell me, what I will be crazily suppressing, what I have to reduce too much. If lambda is too high, to compensate it, what I have to reduce very, very minuscule value, I have to keep it. What is that? The error has to be minimized. This function will be minimized. These weights will be almost minimized, isn't it? Almost, these weights will come to almost near to zero. Do you agree with that point? If lambda is too high, think about it, all of you. If lambda is too high, I have to minimize the error. To minimize the error, I have to keep weights at a very, very low value. Almost weights will be almost near to zero. What happens if all the weights are almost near to zero? Yes, I do have a really large network, but each of the hidden nodes weightages, their weights are almost near to zero. Each hidden node is negligible. Yes, I do have 500 hidden nodes, but almost their weights are almost zero. That means each hidden node is negligible. What will happen if each hidden node is negligible? What will happen to your model? What that will result to? Think about it, all of you. If you have a large network, for the sake of the network, you have it in front of you. However, if each weight is almost zero, think about it. Each weightage of each one, it's almost negligible. That means hidden node is there, but it is not useful. It is almost zero weightage. It is not learning anything. Then what will happen? Will it overfit or underfit? Think about it. If I have several hidden nodes, but their weight is almost zero, that means they are not there. Which means I'm saying the weights, the hidden nodes are there, but theoretically, if you look at it, their weight is zero means what? Let us suppose I have a variable x7, but its weightage, its beta value is zero. What does that mean? Do I really have that variable, or am I using anything from that variable? No. So you will get into underfitting. So when you try a low value of lambda, if lambda is low, then you will have overfitting. Think about it, all of you. When the lambda is low, when it is near to zero, then this term will not be there. Then if lambda is too low, then your model will be overfitted. When the lambda is too high, lambda is too high, then the model will be underfitted. Since you know there is only one dimension that you have to move, if it is underfitted, you increase the lambda or decrease the lambda. Based on that, you can fine tune the lambda. So for all the questions around the network architecture, how do we set the right architecture? All of you think this way. Let us freeze the network. Let us not play around with the network. If you're not even sure what is the initial network, go ahead with an overfitted network. Fitting a perfect model is difficult. Fitting an overfitted model is it difficult? Fitting an overfitted model? If I ask you to build a model, then I'm okay if it is overfitted. It is not difficult. How do you fit an overfitted model? Tell me, all of you. How do you build an overfitted model? When you are in doubt, increase number of layers, number of nodes, then play around with lambda. This is known as cost function regularization. This is how you are supposed to work with network architectures. However, remember, fitting a large network, fitting an overfitted model, do not try to go really, really large network. Maybe it has to be slightly overfitted. Then you can play around with lambda. Usually the values of lambda that are tried are between 0.001 to 0.1. Usually these are the values, but we can try any other values as well. Increasing and decreasing of the lambda may impact the overall model underfitting or overfitting. This is known as cost function regularization. The concept, overall concept is known as regularization. One more thing. Here we have given plus lambda into summation of weights square. New regularized error is actual cost function, actual error plus sum of squares of 8. This is what we are reducing. Or there is another alternative to do this. Okay, what is the other alternative? Sum of squares of absolute values of weights. We can take we can minimize either error plus sum of squares of weights, or there is another alternative to this. We can minimize error plus sum of absolute values of weights. But what I have seen is this is the one that is most widely used. No problem, we can use any one of them. This particular method of regularization is known as L2 regularization. L2 regularization. This particular method of regularization is known as L1 regularization. All right. What is L2 regularization? You minimize the error plus sum of squares of weights. What is L1 regularization? You minimize the error plus sum of absolute values of weights. Okay. This L2 regularization, L1 regularization, if you take neural networks, okay, we are talking about the deep neural network where you have input layer, where you have hidden layer, where you have output layer, etc. What if we directly have input layer and finally the output layer, input to output? If g of x equal to sigmoid, then what is this becomes? What will this network become? If g of x is sigmoid, then what this will become? If it is direct x to y and g of x is sigmoid, then what is this network called outside? What do we call this as? This we used to call it as logistic regression. Yes or no? If g of x is sigmoid, if g of x is linear, if g of x equal to x, then it is regression. Yes or no? Do you agree with that point? Directly x1 x2 to y directly if it is going. Yesterday have we discussed this network way of representing logistic regression? There we gave g of x equal to sigmoid. Sigmoid means what? E power x by 1 plus e power x. If I directly take g of x equal to x, then y equal to w naught plus w1 x1 plus w2 x2. How does this look like? W naught plus w1 x1 plus w2 x2, which is nothing but regression. That means this regularization can be applied on regression as well. If you apply L2 regularization on regression, which means if you have too many input variables and you don't want to use those many input variables, you want to suppress their weightages, which can also be possible. Like at the end of the day, this is a network. You can also keep their weights at a lower level. If you take regression and apply regularization on it, if you apply L2 regularization, that regression is known as ridge regression or decay regression. In regression, we have beta coefficients. You want to suppress those beta coefficient values. You want to keep this lambda value, and based on the lambda value, the beta coefficient values will change. Okay. So if you are following that approach on regression, if you are applying L2 regularization on regression, it is known as ridge regression. If you are applying L1 regularization on regression, it is known as Lasso regression. But usually we don't do this. Usually we follow the traditional approach. When there is multicollinearity, we want to reduce it using VIF values. What if I want to keep all the variables, but still I want to avoid overfitting and all those things? Then you can apply either ridge or Lasso regression. Okay. This is a different approach of keeping all the columns, keeping unnecessary columns, but still I want to avoid overfitting. Do you remember in regression, overfitting comes if you keep on adding the variables, R square keeps on increasing. Then what is the other measure that we used? We used some other measure to tackle it, adjusted R square, and we remove the variables. We don't like unnecessary variables to be kept in the model. Do you agree with that point? Because we felt regression was a simple model, it has to be explained well. There is no point in keeping all the unnecessary variables. But when it comes to ANN methodology and all that, there is no variable, individual variable impact concept. We keep all these variables. So usually ridge and Lasso, we don't really prefer them from the regression, traditional regression point of view. But when you're talking about network architecture, if you have so many input variables, okay, and you want to keep all of them whether they have an impact or not, okay, that means you may get into overfitting issue. You can avoid overfitting by using regularization as well. So yesterday somebody was asking what is ridge regression, what is Lasso regression. So regression with regularization, that means you are keeping so many variables but keeping their weights at a lower value is known as, if you are doing it this manner, that is ridge regression. If you are doing this manner, that is known as Lasso regression. Okay.